Hello everyone, I'm Dr. Hwang, Associate Professor at Mechanical Engineering Department, Wichita State University. In this video, I'm going to introduce my research, which are centered around porous media heat and mass transport using simulations and experiments, especially for efficient cooling and energy systems. My research group focuses on understandings of heat and mass transport by designing novel porous media, developing advanced manufacturing process and performance measurement to develop high heat flux cooling and efficient energy conversion systems. To introduce my research, I can show you a few ongoing research projects in porous media design and experimental performance measurement. Hope you enjoy this video.
One of the technical challenges that you have is a thermal management system, which is simply saying cooling. Cooling is a very important issue in spacecraft, electronic device, and power plant and laser device. The spacecraft needs a cooling device to maintain a desired temperature. The same thing is true in the electronic device. Once you cannot cool it efficiently enough, you end up with being damaging electronic device and a severe accident in the power plant. One way to develop the cooling device is to use the evaporative cooling. Let's say if you have water on your skin, this will cool down by evaporation. So people develop a portable evaporative cooling device. In your CPU cooler, you can use evaporation, and your refrigerator, in order to keep it cool, you can use the evaporative cooling principle. However, one of the issues is that you end up with losing your coolant if you cannot supply the coolant fast enough compared to the incoming heat. So one way you can do is to utilize a capillary flow. The capillary flow is a part of your daily life. When you look at a candle, the flame can melt the solid wax, and the melt wax can flow through the wick via capillary flow. The wick is nothing more than porous media. You can use the same principle to design the wicks for thermal management system, so-called capillary evaporator or wicks.